Namaskar, Jai Hind, Vande Mataram. This is Kunal Mehta from Make Me Scientific, and in this video lecture, we are going to discuss some of the problems related to work, power, and energy. So basically, I have take up an exercise which is on page number 28 from SELINA textbook, grade 10 ICSE. So these are all the numericals which are very important for the board examinations as well as for your conceptual understanding. So now, what formulas we are going to apply over here is what I am going to discuss, right? The force is equal to mass into acceleration, a very, very basic formula of the force. This is also the second law of Newton, right? When somebody says the force of gravity, that means we are asking you about the weight of the object, and weight of the object is simply m into g, where g is the acceleration due to gravity. And if you want to write down the entire answer in Newton, so this has to be in kg, or and this has to be in meter per second square, or Newton per kg is also the correct one. Then there is also one more unit of weight, that is kgf, kilogram force, and remember that 1 kilogram force is equal to 10 Newton, approximately 9.8, sorry, approximately 10, more precisely 9.8 newtons, right? That we will give you in each of the problems. You don't have to worry about it. If it is not given in the question, you may take acceleration due to gravity as 10 meter per second square. But if given whatever 10 or 9.8, use that value which is given in the numerical. Now, power is equal to work divided by time. This is the formula for power. You may also use energy upon time. The potential energy is equal to m into g into h, where m is the mass, g is acceleration due to gravity, h is the height of the object above the ground, right? Kinetic energy is equal to half mv square. Then another formula for power, that is force into V average. Please understand this. This is not force into any kind of velocity. This is average velocity, and I am going to lay much more emphasis to these problems. Also, there is a link which is given in the description that how this formula can be derived. So I suggest you may also watch that video for the better understanding of the topic. Now, whenever I say power input, instead power rating word can also be used. Efficiency is equal to power output upon power input into 100%, or you may use work output upon work input times 100%. So these are some basic formulas, and even there may be some more formulas that may come into the picture. But as we discuss the numericals, I will also keep on discussing them. There is one more formula which pops up into my mind now, that is work done is equal to force into displacement into cos of theta, where theta is the angle between force and displacement. This formula is to be used when the direction of force and displacement are not same. So suppose there is some angle theta between force and displacement, then you go for this problem. Otherwise, simply if force and displacement are in same direction, this theta turns out to be 0 degree and cos 0 is 1. Cos 0 is 1. So this formula simply reduces to force times displacement. So you use this when force and displacement are parallel in the same direction. If they are not parallel, if they have some angle, then go for f into d into cos theta. So now let's move on to problem number 1. The problem number 1 says that a body is acted upon by a force of 10 kgf. So the value of force is 10 kgf and 1 kgf is 10 Newton, so it is 100 Newton. Please be careful about that. Displacement is given to you as 0.5 meters, and the angle between the force and the displacement, if it is same. So the first question says that theta is equal to 0 degree. Under that situation, work done is equal to force into displacement. So 100 Newton times 0.5 meter. This answer turns out to be 50 Newton meter, that is joules. So please understand, I have seen many students who are directly multiplying 10 kgf into 0.5, and they would land up into the trouble. Please note that the work done unit is only joule if the force is in Newton instead of this kgf. So you need to convert kgf into Newton and then find out the answer. Now, the second part states that theta is equal to 60 degrees. So work done is equal to F into D into cos theta. So again 100 Newton times 0.5 meter, and cos 60 is half. Cos of 60 degree is half, right? So you will get your answer as 25 joules. The third says that when the force and displacement are normal to one another, normal means at an angle 90 degree or perpendicular. So I should be saying that theta is 90 degree. The work done is equal to F into D into cos theta. So 100 into 0.5 meter into cos 90. Cos 90 is 0. So your entire answer is going to be 0 joules. No work is done. Right? Like that. Let's move on to the second problem. A boy of mass 40 kilograms. So this is 40 kg. That means the weight of this person is going to be mg, and here we are being clearly said that g is 10. So 40 into 10, so this is 400 Newton, that is the weight of the boy. Calculate the force of gravity. So the force of the gravity itself is the weight that we just now calculated as 400 Newtons, right? Then the work done by him against the force of gravity. Now this essentially means what? You should understand it. Let's suppose this boy is standing here on a ground, right? So that means 400 Newton is the force of gravity. The earth is pulling that boy with a force of 400 Newton towards it. Correct? Now this boy is actually lifting his own weight above the ground. So he's climbing up at a distance of 8 meters above the ground, and the time is 5 seconds. So you just imagine it like this, that he is carrying a load of 400 Newton. This is a load of 400 Newton that he wants to carry at a height of 8 meters above the ground. Sorry, this is 8 meters. So how much upward force he will need to apply in the upward direction? Because see, 400 Newton is the weight of that box. So if you need to lift the box, you have to apply practically more amount of force than 400 Newtons. But if you do that, suppose if I apply 401 Newton in the upward direction, then there will be some net force acting on the box in the upward direction, and the box will start accelerating in the upward direction, and we don't want that situation. We want that the box should be going in the upward direction with constant speed. So we would be saying that we will apply exactly the same amount of force in the upward direction so that this particular box does not accelerate. In this situation, the box will be lifted up and it will be going in the upward direction with constant speed, right? So the work done by the boy in lifting this box upwards is this force applied times the displacement, which is 8 meter. So that is 400 Newton times 8 meter is equal to 8 4s are 32, 3200 joules is the correct answer. So the same thing which I had replicated with the example of the box, he himself is carrying his own weight at a height of 8 meter above the ground. Now few facts that I would like to state over here. If the box would have gone straight upwards like this to a height of 8 meter above the ground, or if the box might have gone through stairs and finally reached at the same location, then also the work done remains the same. I would also like to give you the shortcut. Work done against the gravity is equal to the potential energy. So simply if you find the potential energy, that is equal to mgh, you would be getting the same answer. So the mass is 40 kg, g is 10, and again height above the ground is 8 meters. So again this is 3200 joules. So the work done against the gravity is equal to the potential energy, because whenever the work is done, either the body gains kinetic energy or it gains the potential energy. In this situation, since the body is moving with constant speed upwards, there is no change in the kinetic energy. No change in kinetic energy. It is going with constant speed. So no rise in kinetic energy. Yes, but the potential energy is increasing. So the amount of work done is equal to the increase in the potential energy. That is this. Right. Now, finally, we will calculate the power. And the power is equal to work done divided by time. And please note that the time should be in seconds in order to get the answer in watt. So if you calculate this one, you will be getting the answer as 640 watt. Right? That is the answer. Let's move ahead to problem number 3. And problem number 3 states that the man spends energy or the work done that is equal to 6.4 into 10 raised to 3 joules. Kilojoule means this. So basically 6400 joules, and then the displacement is given to you as 64 meter, and we are supposed to find out the work done and in the direction. So that means the angle is theta degree, sorry 0 degree. So we don't have to worry about that. Simply work done is equal to force times displacement, and the 6400 joules. Work done and energy are the same. So force is given to is which he applies the force, and we are supposed to find out the force. Displacement is given as 64 meters. So the maths is very easy over here. The answer is going to be 10 newtons. Correct? Did I miss out on anything? Yeah, I missed out on 10. So the force is 100 Newton. Basically 6400 divided by 64 is 100 Newton. And please understand, joule can be written as Newton times meter. So meter will get cancelled. Answer will be in joule. That is the answer to the first part. The second part states that the power spent. Power is basically energy or work upon time. So you just plug in the value 6400 joules and then divided by 2.5 seconds. This you will get your answer in watt, and the same answer in watt divided by 746, you will get your answer in horsepower, and this answer you will get as 3.43 horsepower. And why it is like that? Because 1 horsepower is approximately equal to 746 watt. So this simple calculation I am leaving it on you guys. I think that you will be able to do it very well. Moving on, problem number 4. The weightlifter lifted a load. Again, please see that this is in kgf, and the answers are all mentioned in the SI unit. So the weight is given to us as 200 kgf, which is equal to 2000 newtons. Height above the ground is 2.5 meters, and then the time is given to you as 5 seconds. Work done is equal to force times the displacement, and here there is no cos theta because the weight lifted is in the upward direction, that is in the direction of the displacement. So the theta stays 0 degrees, right? So force multiplied by the displacement, force is 2000 Newton times, and this is the weight lifted by the lifter himself. So the work is done basically by the weightlifter, and that way work done is the loss of energy from the body of the weightlifter, and that loss of energy will be credited into the potential energy of the weight, because the potential energy of the weight is increasing, so somebody has to lose the energy, and that is the weightlifter loses energy. Same amount of energy is being converted into potential energy of the weight. You can also simply use formula as mgh, as I told you earlier, times the displacement, that is 2.5 meters. So this answer is basically 5000 joules. That is the work done. This is the answer to the first part. Second, if you want to find out the power is work upon time, energy upon time. So 5000 joules divided by the time taken, which is 5 seconds. So joule per second is watt, so answer is 1000 watt. This is the answer to our problem. A machine raises a load of, so load or the weight is given to us as 750 Newton. Height above the ground is 16 meter. Again, the time is 5 seconds, right? I would be discussing this problem in a little bit different manner. Please understand this one, that 750 Newton is the load, which is the weight which is in the downward direction. So if the machine wants to uplift this load, the machine has to apply 750 Newtons. If it applies more than that, then the load is going to accelerate in the upward direction. We are not going to take up those parts. We want the load to be lifted in the upward direction with constant velocity. So here is this particular load going up in the upward direction with the same amount of force, and the displacement is again given in the same direction, so that is 16 meter. So if you apply this formula, work is equal to F into D into cos theta. The force applied, this is the force applied, and the displacement are in same direction, so theta is 0 degree and cos 0 is 1, so simply F into D. So that is 750 times 16 meter, and if you calculate, you will get your answer as 12,000 joules. Now if I find the power is equal to work divided by time, so that is 12,000 joules divided by the time is given to you as 5 seconds. So basically this is 2400 joule per second. That is the answer to the problem. Moving ahead, the electric heater of power is given to us as 3000 watt, because that is 3 kilowatt. The time is given to you as 10 hours, and how much energy does it consume, and in kilowatt hour and joule we are supposed to write down. So I had already mentioned a few of the tricks in my previous videos, that you simply write down power multiplied by time. Let it be in 3000, let it be in 3000 watt times 10 hour, and I should not convert this into watt, so let it be kilowatt into 10 hour. So this is basically 30 kilowatt into hour. So this kilowatt hour itself is the unit of energy. So this is the answer to our first part, 30 kilowatt hour. Now we do know that 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joules. That means 30 kilowatt hour is equal to 30 into 3.6 into 10 raised to 6 joules, which turns out to be 1.08 into 10 raised to 8 joule. That is the answer to our problem. So now let's move on to problem number 7, and it says that the water pump raises 50 liters of water, and the density of the water is also given to us, height above the ground 25 meters, and the other data. So how would I look at this problem is, I would consider water to be a box. Please consider that there is a box which is itself made up of water, and then the mass of this block would be equal to density times the volume. So 1000 kg per meter cube is the density of water, and the volume is given in liters. So you can't simply write this and solve the problem. That would be practically incorrect. So you should be saying that 1 meter cube is, ideally this is not a suitable method in the exams. This video is just meant to explain you. So I'm explaining this in a different manner. But when it comes to writing the exams, you can directly skip few of the steps and write. I'll let you know. 1 meter cube is equal to 1000 liters, which means 50 liters is equal to 1 upon 50 upon 1000 meter cube. So this is the volume which you need to plug it over here. So the mass of 50 liters of water, that is equal to 1000 kg per meter cube, times the volume is 50 by 1000 meter cubes. So now meter cube, 1000 goes off. So the mass of water is 50 kilogram. So ideally we should remember the shortcut, that 1 liter of water has mass 1 kg. All right. So now I would consider this box which is made up of water itself. Its mass is 50 kilograms. So its weight is 500 Newton in the downward direction. Correct. If I want to lift this to a height of 25 meters above the ground, 25 meters above the ground, I will have to apply applied force in the upward direction, same as that of the weight of this entire block of water. So 500 newtons of force I will apply it in the upward direction. Displacement is in the upward direction. So W work done is equal to F times D. Cos 0 is 1. So force applied is 500 Newton times 25 meters. 25 5s are 125. 12500 Newton times meter is joule. So this is the work done by you, and now the power is the work done upon time taken, that is equal to 12500 joules divided by 5 seconds. So it will be 2500 joule per second is watt, right? So this is the answer to the problem. You can also do it in the another way. You can simply find the difference in the potential energy, because work done is simply the increase in the potential energy. So you can simply use the formula mgh and you will get the work done. All right, and divided by the time taken, you will get your answer as joules. Okay, let's move on to the next problem. Yeah, this time please be a little bit careful that the efficiency is given as 40%. So you've got to be very, very careful here. Okay. So the pump is used to lift 500 kg of water. So the weight of the water is 5000 newtons. Provided G is 10. Yeah, it's given. And we are lifting it from a depth of 80 meters. So it is similar that we are carrying a block of water from height is equal to 0 to a height 80 meters above the ground, which is one and the same. Here you are pulling the water from down to up or from the ground level to up, one and the same thing. So the height above the ground or the depth itself is 80 meters. So now you can very well find out the work done, that is force times displacement. Force is equal to the weight of the block of water. So that is 5000 times the distance, that is 80 meters. So 8 5s are 40. Then 1, 2, 3 and 4 zeros. So this is the joules. This is the original work done by the pump, right? Now the power at which the pump works, that is the power, this which we have found out is the power output. This is the work output and this is the power output, because when the machine does something, it is the output of the machine. So work done by the pump, that is work output. Power at which the pump works, that is power output. Power rating means power input. Okay, so we have found this is the work done by the pump, so this is work output, right? And then if I am being asked to find out the power output is equal to work output divided by time, and the work output is 4 lakh, 4 into 10 raised to 5 joules divided by the time taken is 10 seconds. So basically 1 0 goes off. So this is 4 into 10 raised to 4 watt, that is the power output. Now efficiency is equal to power output upon power input times 100%. And 40% is given to us, that is 40%, that is equal to power output, that is 4 into 10 raised to 4 watt divided by power input is what we are supposed to find out. So I am just writing as PI times 100%. Please understand, if you are writing efficiency in percentage over here, you need to write down 100%. Percentage goes off, 110 goes off, 4 goes off. Then simply power input, that is equal to 10 to the power 5 watt. That is the answer to the problem, which is also written in the answer as 100 times 10 raised to 3 watt, and this 10 raised to 3 watt is known as kilowatt. So the answer is given as 100 kilowatt. An ox can apply a force of this. So the force is given to you as 1000 Newton, and it is able to pull the cart with a constant speed. So the speed is 30 meters per second. We are supposed to find the power. Now, I am sincerely requesting you at this moment of time, I find this problem to be a bit wrong. Why? Because when you exert the force, what happens? The cart accelerates. So what would happen? The velocity should increase. And here what is given in the question? They are saying the cart is going with constant speed. So what I think should be happening over here is that when this cart is being applied with a force of 1000 Newton in this direction, there might be some frictional force. It can't be this much of the friction, but still let us assume that the frictional force is also acting in the same direction. Sorry, in the opposite direction. So the net force acting on the cart is 0, which means the acceleration is 0, which means the speed is constant. This is what might be happening in this situation. Otherwise, I have seen many students who commit the same mistake which I am mentioning over here. Power is force into velocity, so force is given to us as 1000 Newton times velocity is 30 meter per second. Without any thinking, they directly write the answer as 30,000 watt, which I don't think is the correct answer. The correct answer should be explained in this way, that power is equal to force into V average. So since power is equal to force into average velocity, this is force time average velocity is initial plus final divided by 2, correct? But here the value of force is 1000 Newton times the average velocity is 30 plus 30 divided by 2, so again it is 30 meters per second. I still feel that this is an incorrect numerical. It is because when you apply the force, the net force itself becomes 0, so there is no use of calculating, but still the answer turns out to be 30 into 10 raised to 3 and divided by, okay, this simply Newton meter per second is watt, so this is 30 kilowatt. That is the answer. I personally feel that there is something wrong in the question, because what should happen is the constant word itself is incorrect. So if the net force is 0, the body goes with constant velocity, but somewhere down the line I feel that this force F, right, that we have used as 1000 Newton should not be used. But still, for solving the problem, this is how we need to go ahead. Next question. The power of the motor is given to you as 40 kilowatts, so that is 4 into 10 raised to 4 watt. At what speed it can raise a load? Again, a similar kind of question, and we should again use the formula power is equal to force into V average. Now here, when you are lifting anything, we would say that the load is 20,000 Newton. So 2 into 10 raised to 4 Newton is the weight of this particular load. And you are exerting a similar load, similar force in the upward direction like this. So the force applied is to be plugged in over here. So P is equal to F, that is 2 into 10 raised to 4, and this is U plus V divided by 2, V average. So this is 2 into 10 raised to 4, and since U and V are same, because the body is going upward with the constant velocity, so U and V are same, so again 2 would get cancelled, and V would be the V average, but it can be any velocity, but that is constant, right? And force is given, the 4 into 10 raised to 4. Power is also given, so basically 10 raised to 4. So velocity is 2 meter per second. That is the answer to the problem. Right? This answer is a bit incorrect. Here it is 2 meter per second. The force value is given to us as 150 Newton. Again, it goes with constant speed. V is equal to 10 meter per second. So power is equal to force into V average. The applied force has to be equal to the force of friction, but here we are going to substitute the same value, 150 Newton times the average force, sorry, the average velocity is again U plus V by 2. So 10 plus 10 divided by 2, so again 10 meters per second. So this is equal to 150 into 10, so that is 1500. Everything is in SI units, so I'll get my answer in watt. Now, this is a good problem. The boy weighs this much newtons and he climbs off 30 steps. So one step is, I think, 20 centimeter high. So if the boy climbs up by 20 divided by 100 meters, because this is in centimeter, I need to convert that in meters. Then he has to carry his own load in the upward direction. So the weight which he is carrying is his own weight. So he has to apply a same force in order to lift the load in the upward direction, his own weight. So that is 350 newtons. And this is one step. Similarly, 30 step means the work done by the boy, that is equal to force applied times 20 by 100 meters into 30. Now this is the total work done. So 0, 0 getting cancelled, 0, 0 getting cancelled, 35 2s are 70, 73s are 2100 joules. That is the work done, and the power, that is equal to work done divided by time. So that is 2100 joules divided by the time is 60 seconds. 0, 0 getting cancelled. This is 6 1s are 6 3s are 18, 6 5s are 30. So this is 35 watt. That is the answer to the problem. Again here it takes 20 seconds for person A. So this is person A, this is person B. Now 50 kg, that means the mass of this person is 500 Newton. While another person of same mass, so again 500 Newton is the weight of the person, okay, climbs up the stairs and does it in 15 seconds. So here time is 15 seconds, here this is 20 seconds. Now we are supposed to compare the work done. Okay. Now if you look carefully, you assume that the person himself is carrying a load of 500 Newton up by a distance, say D. Okay, because he climbs up the stairs, same stairs is being climbed by the another person. So in both the cases, the load is the same, the weight of the person itself, 500 Newton, 500 Newton. Displacement is same in both the cases. So the work done is force times displacement, that is 500 times D. Here also the work done by B, work done by A is again 500 times D. So if you find out the ratio work done by A upon work done by B, that is 1:1. That is the answer to the first part. Now the power of A to the power of B, that is equal to work done by A divided by time taken. I need not to convert everything into SI unit, even though it is given in SI unit. So this is 20 seconds, right, divided by work done by B in 15 seconds. So the power of B has to be more than the power of A. So if I calculate WA upon 20 divided by, so multiplied by 15 upon WB, work done is same, and this is 5 3s are 5 4s are. So the power of A upon power of B is 3 by. This is the answer to the problem. Now the 14th question says that a boy of weight, please understand the weight is 400 Newton of the boy, okay, and climbs up 30 steps 20 centimeters each. So the work done by the boy is equal to force times displacement. He is climbing up, so the displacement as well as the force or the weight are in the same direction. I mean the force which he is applying against the weight in order to lift his own weight. So if my body is 500 newtons if it weighs 500 newtons, I will have to apply 500 newtons in the upward direction to lift my load. So 400 newtons, and the total displacement is 30 steps and each is 20 centimeter high. So I need to convert that into meter. Correct? And that happens in time 4 minutes. Which is equal to 6 4s are 24, so 240 seconds. So if I calculate the work done by the boy, that is 2020 getting cancelled, 4 3s are 12, 12 2s are 24, 2400 joules. That is the work done by the boy. In the same way, if I calculate the work done by the girl, let me calculate the work done by the girl, that is equal to 30 kgf, that means 300 newtons, and 30 steps times 20 by 100 meters. So 0 to 0 getting cancelled, 3 3s are 9, 9 2s are 1800 joules. This is the work done by the girl. And please understand the word compare is written over here, so you need to find the ratio. Compare the work done, so the work done by the boy divided by work done by the girl, that is 2400 joules divided by 1800 joules. 00 joule, 00 joule cancel. 3, okay, this can go by 2 12s are, 2 9s are, 3 4s are, 3 3s are. So 4:3 is the correct answer, or 4 by 3. Now the power developed. Let us find out the ratio of the power by the boy, that is equal to 2400 joule divided by how many minutes? 4 minutes. Oh, I should not have converted this into seconds. That's totally fine. 4 minutes. You will understand why. Power by the girl, that is equal to 1800 joules divided by how many minutes? 3 minutes. So power of the boy divided by power of the girl, because it is compare, so ratio, so 2400 joule upon 4 minutes times 3 minutes divided by 1800 joules. Minutes getting cancelled, so we need not to convert that into seconds, right? And this 2400 divided by this 1800 was already 4 by 3, so 4 by 3 into 3 by 4, so answer is 1:1. That is the answer to the problem. So whenever you are being asked to find the ratio, please do not convert minutes into seconds. That is of no use. Now in the last part, we are being said that the man raises the box of mass. So the man, this is the work done by the man, that is equal to 50 kg. So 500 Newton is the force applied against the weight, times the displacement, that is the height, so that is 2 meters. So the work done is 1000 joule, that is the work done by the man, correct? While the another man, okay, I should say man 1, and work done by man 2, raises the same box to the same height. So that means again he has to apply same amount of force, same distance. So the work done by man 2 is again the same, 1000 joules. So compare means the ratio. So work done by man 1 upon work done by man 2, the ratio is 1:1 or 1/1. Now the ratio of the power, or simply they are asking find the power. So power by man 1, that is equal to work done by man 1 divided by time taken by the one, that is 1000 joules divided by 20 seconds. Yeah, because the time is 20 seconds. So the answer is 50 watt. Whereas power by the man 2 is equal to same work done, 1000 joules divided by the time taken is 50 seconds. Slow person, right? Okay. So this is equal to 20 watts. That is the answer to the problem. So I hope you might have understood. I only felt one confusion here in this problem, and you may give your honest opinion in the comment section. I found this part to be a little bit wrong, because see, when you are exerting the force, the body can't go with constant velocity. So anyhow, if you try to justify the problem, I find this question to be a little bit wrong. You may even give your opinions, honest thoughts on these questions about the same, right? So thank you very much for watching the video. And if you have any doubts, please do comment in the comment section.